Hi guys, it's Silverly B here, and today I'm going to be showing you how to make the dungeon generator that we did on the previous tutorial a little bit more interesting. So here's what we're going to be doing. This tutorial is going to be picking up from where we left off on the previous video, so you should watch that first before you try this one. If you're ready, then let's begin. Here we have our scene from where we left off. Taking a look at our room, we can see that there are a few differences from where we left. The first one being here, we can see that we have now on our door, we have the door prefab and also the lamp right here. And this lamp also has a point light that is lighting our room. And that's what's different here. And we can see as well that we now have a parent object that has the door and the lamp separated, okay? So this parent object is what we're going to be using here inside of our room behavior. Because whenever we don't have a door here, we are going to be disabling the entrance as well as disabling this light right here. So that's our room. And all the assets that we're using to build our dungeon, just like on the last tutorial, they come from the stylized hand-painted dungeon asset package that was made by L2S Arts. And both the link to the asset package on the Unity Asset Store, as well as the link to L2S's portfolio, will be left down in the description below. So let's take a look at the problem that we have with the overlaying walls on our rooms. If we hit play here, we can see that whenever we have a room, so here this 0, 0 room, and this room is beside another room, in our case the room 0, 1, we can see that the walls here are overlapping, okay? So instead of just having one wall separating our rooms, we have two walls that are overlapping between them. In this current case, it doesn't cause us many problems, but it can, depending on the asset that you use for the door or what type of game you're building. To fix this without using code, it's very simple. We just have to come here, and what we're going to be doing on this room prefab is just we're going to be picking up a wall, duplicating it, and positioning it here on the right entrance. And now we're going to be doing the same for this down entrance that we have right here. Just duplicate this wall, position it accordingly, and here you have it, a little entrance between the room. Now all you have to do is here on this right door object, we're going to be selecting all of these and dragging them into this right door object. If we drag and drop it inside of here, we can see that now it is inside the right door, and whenever the right door is supposed to be activated, this is also going to be active. Whenever the right door is supposed to be inactive, this will be inactive as well. We're going to be doing the same for this down door. And going back to our scene, here on our generator, we just need to change the offset between each room. Right now is 6 by 6. But because of that change, we need to change this to 8 by 8. Hitting play, we can then see what this looks like. We can now see that no walls are overlapping and we have a little entrance between each room. This is a solution that doesn't use any additional code, and it's very good if you're, for instance, trying to make a 2D dungeon, because then you have very distinct corners for your rooms and all of that, and you want your rooms to be very well defined. So yeah, here we have it. We can pause this, and going back to our room, what we're going to be doing is we're going to be deleting this, because, well, while this is a solution, maybe you want your rooms to still be close to each other, but you don't want the walls to be overlapping. To do that, we're going to be using code and colliders to check if any walls or any columns are overlapping. we're going to start with the walls because the logic is simpler. Basically, you only can have 2 walls overlapping. And going back to our scene, we can see that, first we need to adjust this offset to 6 by 6 again. We can then hit play. And here we can see that whenever we have 2 walls overlapping, it can only be the up wall overlapping with the down wall or the right wall overlapping with the left wall. This means that we just need to choose one of these walls to put a collider in and make the other wall check to see if there is a collider where it is positioned. We can then go into our scripts, and here we're going to be creating a new C# script. This one we're going to be calling wall collision. Opening this, we can start by erasing this update function, and this script is what is going to be checking to see if there are any colliders on the position of the current game object. To check that, we're going to start by getting all the colliders that are currently colliding with our object, and we're going to be calling this colliders. This is going to be equal to physics.overlapSphere, and inside of here we can inform the position of the sphere and its radius. So we're going to be using transform.position, and the radius is going to be a very small radius to check if there are any colliders right there where the wall is. So we're going to just use a very small number. You can use an even smaller number if you want to. This colliders is an array of all the colliders that are overlapping this sphere positioned at our current position and with a very small radius. What we want to do is right here, we're going to go through each of these colliders. This is going to be a collider that we're going to be calling collider, and they are in our colliders array. And for each of these colliders, we're going to be checking if they have a tag that is equal to wall. If they do, this means that this object has collided with a wall. What we're going to be doing is we're going to be destroying this current game object, and since we've just destroyed this object, we can then just return from this function and end it right here. We can save this and go back to Unity to check to see if this is working. Going back to our room, we can start by selecting the walls that we want to have the collider and the walls that we want to have the collision check. You can choose whatever wall fits better with what you're trying to do, but between the up and down walls, you have to choose one to be the collider and one to check for the collision, and between the left and right walls, you have to choose one to be the collider and the other to check for the collision as well. I'm going to be using the up walls and the left walls to have the wall collision, so we can add the wall collision script here. And I'm going to be choosing the down walls and the right walls to have the collider and to have the wall tag. Here, I'll just be creating a new wall tag that we're going to be using on these elements. One thing that is important to note is that right here, we're not selecting the parent to add the script to check the collision, because the lamps that we're using are associated with the parent. So if we destroy the parent object, we're also going to be destroying the lamps that are supposed to be there on that door. And all we want to do is just to destroy the overlapping door and not the decoration that is not overlapping. So here in our tags, we're going to be selecting the wall tag. Going back to our scene, we can hit play and check to see if this is working. Here we have all of our rooms. If we go to the room 0 and let's disable it, we can see that currently we don't have these walls, even though we have this decoration, because these walls right here were destroyed when the room was being built. If we again activate this, we can see how it looks like from the other side, and it looks perfectly fine, perfectly normal, and our decoration is still right here because only the left door was destroyed. This left door parent wasn't, and it appears that it's working correctly. Now, if we were to take a look at our columns, we're going to see that it has a different type of problem. It's no longer like the walls. No, here, all the columns are overlaying each other. On this point where we have 4 rooms that are meeting, we have also 4 columns that are overlapping. No longer can we just use a collider in one of the walls and a wall collision check on the other wall. This is no longer going to be separate. All the columns are going to have colliders, and all the columns are going to have to check to see if it is currently colliding with another column. The problem with that is that the physics.overlap sphere is also going to be returning its own collider. So to deal with that, we're going to go back to this wall collision script, and after we've run this, if it hasn't destroyed the current game object and it hasn't returned, what we're going to be doing is just we're going to get the component that is supposed to be our collider. So we are going to be putting a collider on our columns, and we're going to start this as disabled. And once we've checked this and we know that there are no walls currently there, we're going to be enabling this. So .enabled is going to be equal to true, and this collider on this column is going to be telling us that this is occupied, that you can't put another column there. Going back to our prefab, we can just select these columns. We're going to be adding to them a box collider that is going to be disabled at start. We're going to be using the wall tag here, and we're also going to be adding to it the wall collision script. Another thing to note is that here on the walls that we just checked for the collision, we can now also add a collider, because mostly whenever we have a room, we want its walls to be solid. And if we just add a collider here, we can also set it disabled, use the wall tag as well, and whenever this room spawns and these walls are not overlapping with any other walls, then it's going to be having a collider and acting normal as it should. There's only one more thing that we should fix, which is if we go here on one of our walls and edit its colliders, we can see that it overlaps the column. To fix this, in order for this to not cause us any problems, what we're going to be doing is just editing all of these colliders. Once we've done this, we can go back to our scene, hit play, and check to see if this is working. Right here on our first room, we can disable this, and as we can see, these walls and these columns that were overlapping with these walls and these columns of the first room have now been destroyed. Now we no longer have overlapping walls and overlapping columns. What we're going to be doing now is we're going to be changing our generator in order for it to generate random rooms and not only just this current room that we have. Opening this, we can see here our generate dungeon function, and all we need to do in order to generate random rooms is just use an array here, and let's call this rooms because now we can have more than one room. Now this is going to be given an error. All we need to do to fix this is just get a random room. So for this, we can use random.range and select a number between 0 and the total number of rooms. And this is going to be a random room out of our rooms array. Saving this, we can head into Unity, and inside of here, we just need to create different types of rooms. What I'm going to be doing is I'm going to be changing the light color of all of these rooms. So now we have our normal room, a green room, a blue room, and also a pink room. Now all we need to do is here on our dungeon generator, it's going to be asking for the rooms that it's supposed to be using. We can lock this on the inspector and select all of our rooms and drag and drop them inside of this rooms array. Now, when we hit play, we can see if there are different types of rooms. And as we can see right here, there are many different types of rooms, and now it has randomized our rooms. At last, what we're going to be doing is we're going to be using rules in order to set what type of room is going to be spawned at what part of our dungeon. Going back to our dungeon script, we can start by creating a new class that is going to be setting our rules. This class is going to be called Rule, and it's going to be asking for the room that we're going to be using, so public game object room, and it's also going to be asking where it's supposed to be positioned, so the minimum position that it can be at and also the max position that it can be at. Then we're going to be using a public vector2, and we can use a vector2 int. I was asked on the previous tutorial why I didn't use a vector2 int and use a vector2 only, and basically it's because I forgot, but for our purpose it's better to use a vector2 int. So here we have the minimum position of this room, and right here, as you can see, I used a vector2 here, and this could have been a vector2 int, and all we need to change is just to erase this math function floor to int. Going back here, we can use another vector2 int that is going to be our max position. Another variable we're going to be using here is a public bool to know if this is an obligatory room or if it's optional. If it's obligatory, then it has to spawn at that position, but if it's optional, then it has a chance of spawning there. To handle whether or not this room should be spawned in a certain position, what we need to do is we need a function here that is going to be returning to us an int. That is going to be our probability of spawning. And we're going to be passing the x and the y of the position that we want to check. Now this is going to be returning an int. What this int is supposed to be is if it returns a 0, this means that it cannot spawn at that position. If it returns a 1, it means that it can spawn at that position. If it returns a 2, this means that it has to spawn at that x and y position. Okay, so the first thing we need to do is we're going to be returning 0, and this error right here is going to go away. And now all we need to do is we need to check if x and y are between the min position and the max position. So x should be greater or equal than the min position dot x, and it should also be less than the max position dot x. As for y, it's going to be pretty much the same. We just need to select this here and paste it over here. But instead of x, this is going to be y. And here, it's going to be y as well. Okay, so if this position is valid, if x and y is between the min position and the max position, what we're going to be returning is either 1 if it's optional or 2 if it's obligatory. So right here, if it's obligatory, we're going to be returning 2, else we're going to be returning 1. Now I know that this is written only in one line, but this could be shortened further into return obligatory, and we're going to be using a question mark to mark an if statement here. And if it is obligatory, we are going to be returning 2. If it isn't, we're going to be returning 1. So we can shorten that if statement into this right here. Now that we've created this class, we're going to be making this public, and we're going to be using system.serializable because we want to use a variable of the type of this class, and we want to access these sorts of properties from the inspector. So we're going to be using system.serializable. Inside of here, our rooms array is no longer going to be a game object array. Now it's going to be a rule array. Going back to our generate dungeon function, where we instantiate our room. Now this rooms is of type rule, and to get the game object that is supposed to be instantiated, we need to use .room. But currently we're still just using a random room that we chose right here. In order to work with the rules that we're going to be setting, what we're going to be doing is first we're going to be setting this random room as -1, and we're going to be creating a list of ints that are going to have the index of all the available rooms. So all the rooms that can be spawned at that ij position that we're currently at. We're going to be calling this the available rooms, and this is going to start off as an empty list of ints. Now we need to go through all of the rules that we have. We're going to be using a for and a k as an index for this for, and this is going to go through all of our rooms. Inside of here, we're going to get the probability of this room being instantiated there. So whether it can be instantiated, whether it cannot be instantiated, or if it must be instantiated at that position. We'll use then rooms and use the index of the current room, and we'll get the probability of it spawning at the ij position that we're currently at. Now if this is equal to 2, this means that the random room is not random at all. It is a room that has been set as obligatory at our rules. So random room is going to be equal to the current index. Once we have an obligatory room, we need to then break out of this loop, and we're just going to be instantiating this room. This means that whenever you're setting the rules, the first rule that you set as obligatory is going to be taking precedent over the last rule that you set as obligatory on the same position. Else, if this is equal to 1, this means that it can be instantiated at that position, not that it must. So we're just going to be adding this index into our available rooms array. Once we're done with this, if the random room is still equal to -1, this means that we haven't encountered any obligatory room. Then what we're going to be doing is we're going to be selecting an available room. So if available rooms.count is greater than 0, if there is an index that we can choose from, then our random room is going to be equal to a random index. Now we need to handle what happens when we don't have any available room. And here we're going to be using else. Inside of here, you can handle this however you like, but I'm going to be using a default room that is going to be the first element of our rooms array. So now that we handled the index that we're supposed to use, this should be working. We can save it, go back to Unity, and inside of here, now it asks us for the room that we're supposed to be using, the minimal position, the max position, and whether or not it's obligatory. We can go into our prefabs and drag into each of these positions the rooms that we're supposed to be using. If you take a look at our size now, once we've changed this to a vector to int, it has changed back to 0, 0. We're going to be changing this into a 10 by 10 dungeon. Now this first room is going to be very general. This second room is going to be obligatory at the first position, and this third room is going to start at the 5th position. And at last, this fourth room is going to start at the 8th column. What we're going to be doing is we're going to be setting a limit here on this first room up until the 5th position, the 5th column and the 5th row. And when we hit play, we can check, and right here on the 8th position, we can see that there are pinkish rooms spawning here, and the bluish rooms start right here. So now we've managed to establish rules in order to position our rooms correctly. This was it for today, guys. If this video was helpful to you, don't forget to leave a like. If you have any questions, leave them down in the comments below. And for more videos such as this one, please consider subscribing. Thank you so much for watching. Bye!